Hello, chemists. This is Miss Placino, and you're watching lesson 6.4 on mole conversions. In today's lesson, we're going to work on converting between units using the mole. So we're going to take some of those skills that we developed during lesson 6.2 with dimensional analysis, and now apply it to something a lot more focused on chemistry. All right, goals for today's lessons. You should be able to recall the value of Avogadro's number. You should be able to recall the value of molar volume at STP. And most importantly, you should be able to convert between units using the mole. For today's lesson, you definitely are going to want a calculator and probably a reference table. All right, let's get started. When we talk about a mole in chemistry, this is a unit that is super important because it's going to connect three other units that would otherwise be unrelated. So chemists are very excited about the mole. When we say mole in chemistry, we're not talking about that type of mole. We're not talking about this type of mole. We're talking about a number, specifically 6.022 times 10 to the 23rd, also known as Avogadro's number. And this is just the SI unit of quantity. Just like a dozen means 12, a mole means 6.022 times 10 to the 23rd. Since this is such a gigantic number, it really only makes sense to count things that are super small using the mole. So usually we're talking about things on the scale of atoms or molecules. Wouldn't make sense to count anything large enough that you can really see using the mole. Let's try to perform some conversions with this. So in lesson 6.2, we talked about using conversion factors, which are really just fractions equivalent to 1. So here's another conversion factor for us. 6.022 times 10 to the 23rd anythings. Again, usually we're talking about atoms or molecules equal to 1 mole. Let's try out a practice problem. I've got 1.53 moles of krypton, and I'm trying to figure out how many atoms would be present. So just like before, I'm going to take the number I've been given along with the unit. I'm going to put it over 1 just to keep my work organized, and I'm going to work horizontally. How can I use this conversion factor to get out of moles and into, in this case, atoms? Yeah, if we leave the conversion factor exactly as it is, we can get moles to cancel out. We can get our answer in terms of atoms. Moles cancel, they're in the numerator and in the denominator. And if I punch that into my calculator to the correct number of sig figs, I should come up with 9.21 times 10 to the 23rd atoms. There we go. If you're getting the correct coefficient, but you start getting really strange exponents, that usually means that you've done something strange with how you're entering scientific notation into your calculator. So be careful with that. Go ahead, try this one out on your own and unpause the video when you're ready to check. Okay, I've got my conversion factor set up, 3.98 times 10 to the 24th atoms of zinc. I can take that conversion factor up at the top and basically flip it on its head so that I can get atoms to cancel out and leave me with my answer in terms of moles. Again, I got 3 sig figs to work with. I get 6.61 moles of zinc. All right, hopefully you agree. The mole also can connect volume. At STP, and that just stands for standard temperature and pressure, and for chemistry we use 0 degrees Celsius and 1 atmosphere of pressure, 1 mole of any gas occupies the same volume. It does not matter the identity of the gas. As long as a substance is a gas under these conditions, STP, if I have a mole of it, it will occupy 22.4 liters. So again, whether it's a small monatomic gas or a diatomic gas really doesn't matter. 1 mole of gas, any gas at all, at 0 degrees Celsius and 1 atmosphere of pressure will occupy 22.4 liters. Unless it is specifically stated otherwise, if you're working with a gas, for our class anyway, it's safe to assume we're at STP at this point in the game. So this gives us another conversion factor to use. We've got 22.4 liters of gas. Again, really make sure that you're talking about gases. This does not apply to any other phase of matter. But 22.4 liters of gas at STP is equal to 1 mole. Let's try to use it. I've got 5.53 liters of argon at STP. How many moles would that be? let's see, I'll take my number and unit that's been provided. I'm going to use this conversion factor. If I flip it upside down, I can put 1 mole over 22.4 liters. I can get my liters to cancel out and leave me with an answer in terms of moles. I've got 3 sig figs again, and I'm coming up with 0.292 moles of argon. Let's try out one on your own. Try this, pause the video, and check your work. For the second practice problem, we've got 1.25 moles. We're trying to get it into liters, so I'm going to take the conversion factor up at the top, flip it over, get moles to cancel out, leave me with an answer in terms of liters. Your calculator probably just says 28. Be careful with sig figs. I've got 3 sig figs in my question, or I guess like in my initial value, I should say. So make sure you've got 3 sig figs in your answer. All right, let's look a little bit more at molar volume. I really like questions like this because you don't really have to pick up a calculator, and it's just kind of testing some concepts. So each balloon contains 1 mole of gas at STP. What I would like you to do is try to figure out these 3 questions. Which balloon has the largest volume? Which balloon is the heaviest? And which balloon contains the most molecules? Pause the video, try it out, and we'll come back and discuss in just a moment. First question, which balloon has the largest volume? Ooh, sorry about that. Largest volume. Well, we're told that every balloon contains 1 mole of gas at STP. That means they all have the same volume, 22.4 liters. So they all have equal volumes. Which balloon is the heaviest? This one you do actually have to do a little bit of math. So I know the molar mass of hydrogen is 1 times 2 gives me about 2 grams per mole. CH4, that's 12 plus 4. Gives me 16 grams per mole. And then with nitrogen dioxide, I've got, let's see, 32 plus 14, 46 grams per mole. So even though they all occupy the same volume, when it comes to mass, which one's the heaviest, we do have to take identity into consideration. So NO2 is going to be the heaviest of the 3 balloons, as it's got the greatest molar mass. And finally, which balloon contains the most molecules? All right, well, these are all molecules, H2, CH4, NO2, and they all contain 1 mole, so they must all have 6.022 times 10 to the 23rd molecules. So again, all equal. How'd you do? Hopefully you didn't get tripped up, especially on questions like 1 and 3, but if you did, learn from your mistakes. All right, the last and probably most important, most useful for our purposes anyway, mole conversion is going to be between the mole and molar mass. We kind of introduced this concept in the previous lesson, but just to review. We know that different atoms and molecules have different molar masses. We can really readily calculate that just using the periodic table. So we've got something like NaCl, sodium chloride. I can look up sodium and chlorine on the periodic table, get their individual masses. So sodium is just under 23 grams per mole. Chlorine is about 35.45, 35.5 grams per mole, and just add them up. So I come up with about 58.5 grams per mole. Make sure you're really including that unit. So let's try to do a conversion using molar mass. So this conversion factor is a little bit different. Instead of having a constant numerical value like we did with number of particles, 6.022 times 10 to the 23rd, or liters, 22.4, now we have a little bit more math to do. We'd have to calculate the molar mass of the substance in question. Let's look at an example. So I've got 19.3 grams of P3, elemental phosphorus. I'm trying to find the number of moles. Before I can do any conversion, I've got to find the molar mass of P3. So I've got 3 phosphorus. If I look on the periodic table, its mass is pretty darn close to 31 grams per mole. So that gives me 93 grams per mole. Now I'm able to convert, because if I have 93 grams of P3, I have a mole of P3. So 19.3 grams over 1. I'm going to flip my conversion factor, 1 mole, 93 grams. A little carried away on that line. There we go. Now grams should cancel out and leave me with an answer in terms of mole. I calculate about 0.208 moles of P3. So as you can see, a little bit more work. I have to go through that quick calculation of finding molar mass. You don't have to show me how you find it. I trust that you can do this math either mentally or very quickly in your calculator, but I would like to see your work for the conversion. Go ahead, try out one on your own. You know the routine. Hopefully you calculated the molar mass of calcium hydroxide to be approximately 74 grams per mole. Now we can use it as a conversion factor. I'll keep 74 grams up in the numerator. I'll put 1 mole in the denominator. That will allow me to cancel out moles. And when I do the math, careful with sig figs here, I rounded to 221 grams. If you chose to round down to 220 grams, that's completely fine as well. It's okay if we differ a little in our last digit. Okay, so just to kind of summarize before we get into a couple more practice problems, the mole is going to connect a lot of units that are otherwise unrelated. That's why it's so important in chemistry. So we can just use it as a counting number, and whether you use 6.02 or 6.022 times 10 to the 23rd doesn't really matter all that much. Feel free to use either, but we know that that number represents a mole, and that gives us this conversion factor of 6.02 times 10 to the 23rd over a mole. Remember, we're usually going to count things like atoms or molecules with this number. Molar mass, probably the most useful one for us. Molar mass is grams per mole. Again, you've got a little bit more work. You've got to find the molar mass of the substance you're working with. Really quickly, just kind of add up the masses from the periodic table, and that should do the job. But another conversion factor, your molar mass in grams over 1 mole. And finally, it relates molar volume. 22.4 liters of a gas, any gas at all at STP, will be equal to a mole. So we've got our third conversion factor. There we have it. So without the mole, there wouldn't be any way to connect like volume of a gas, for example, with the mass of the substance. So this is a really important unit, and we'll be using it really throughout the entire school year. Let's get into some more involved practice problems. So all of the problems that we went over together in the notes were like one-step conversions. The practice problems, kind of as you make your way down the page, are going to get more involved from a conversion perspective. All of them are at least two-step conversions. So let's try one out. I've got 91.05 liters of argon at STP. We're going to assume that the number provided is a measured value, just so we can practice with sig figs. And I want you to calculate the number of atoms. All right, so same deal. We're going to start off just by kind of, taking the number 91.05 and the unit, liters, and I'm going to put it over 1. I highly, highly recommend that you work horizontally and you cancel your units as you go. I can't go from liters into number of atoms. I need to kind of take an intermediate step. I can get out of liters and into moles. So I know if I have 22.4 liters of a gas at standard temperature and pressure, that's equal to 1 mole of that gas. Liters are gone, I'm into mole. I know the relationship between mole and number of atoms. 6.02 times 10 to the 23rd atoms equals 1 mole. Mole cancels out and leaves me with an answer in terms of atoms. We're going to treat 6.02 times 10 to the 23rd or 6.022, whichever, as like a definition with an infinite number of sig figs. So if you plug everything into your calculator to 4 significant figures, you should end up with 2.447 times 10 to the 24th atoms. It's really that same idea and same skill set that we learned in lesson 6.2 by kind of setting up all of these conversion factors, getting units you don't need to cancel out, in this case liters and moles, and get into the unit that you need, atoms. Go ahead and try question number 2 on your own and unpause the video when you're ready to check your work. I've got this set up ready to go. I took the number I was provided with the units, and I can't go from number of atoms into mass directly. I've got to use the mole to convert. So I can cancel out atoms using mole as like a counting number, 6.022 times 10 to the 23rd. Now I'm into moles. And I can get moles to cancel out using the molar mass of lead. Element 82 on the periodic table. Its molar mass is roughly 207.2 grams per mole. I'm left with an answer in terms of grams, so when I go through and I do the math, I come up with about 25.8 grams of lead. And that's it. I know I'm kind of repeating myself at this point, but work slowly, work stepwise, and make sure you are taking the extra 2 seconds to write your units. Things get really messy really quickly when your units aren't there. All right, chemists, that wraps it up for today. Thank you for tuning in, and I hope you found this helpful.